everyone, thanks for tuning in for another activity on STEM with Simba. So this week we're going to be making cloud in a jar. So I'm going to give you guys your materials first, and then we're going to do a little background on the activity. So for today's experiment, you're going to need a 1/3 cup measuring cup, some hot water, which I heated up using my kettle, but you can also heat it up on your stove or in the microwave. You'll probably want an adult's help with that one. You'll need a jar with a lid, some hairspray, and some ice cubes. You'll only need about a handful of ice cubes. So let's start by talking about, well, what is weather? What comes to your mind when you think weather? When I think weather, I think about temperature, whether it's rainy or sunny, and maybe depending on the season if it's like snowing. Well, that's exactly what it is. Weather is the daily state of the atmosphere in a given place. And the atmosphere is just a big word for the air around us. But what's somebody called who studies the weather? Well, they're called a meteorologist. Meteorology is the study of the atmosphere, atmospheric phenomenon, and atmospheric effects on our weather. So like I said before, you can think of the atmosphere as the air that surrounds us. It's the gaseous layer, so a gas, like we learned about in our video last week, that surrounds the physical environment that we live on. Let's take a minute to think. Do you think the weather is the same here as it is in another place on Earth? Well, normally it's not, right? Let's say, for example, if I think about here in Ontario, it's normally much warmer than it is in the Yukon or the Northwest Territories, right? Exactly. So what exactly are we talking about when we talk about weather? Well, we're talking normally about the temperature, the wind speed, the humidity. And well, humidity is the amount of water vapor, which we learned about in our last video about ooblex, the amount of water vapor in the air. So let's think for a second. Deserts are normally very dry, right? So they have low humidity, but a place like the Amazon rainforest would have high humidity. We also think about things like precipitation, which is different kinds of water that can fall from the sky. So that would be things like rain, snow, hail, ice pellets, sleet. And changes in atmospheric pressure should also be considered too, because changes in atmospheric pressure can cause thunderstorms or different kinds of storms like snowstorms. And we've been having a lot of thunderstorms lately. So today what we're going to do is we are going to make a cloud in a jar. So the first thing we are going to need to do today is to heat up our hot water, and we're going to take the lid off our jar. So I'm going to plug in my kettle and come back when my water is boiling. So my water is all heated up now. It's just sitting beside me over here on another table, so I have lots of room to show you guys. So the next thing I'm going to do is I'm going to flip my lid upside down, and I'm going to put a handful of ice cubes in there, okay? Do you guys see that? So I'm going to need somewhere to dispose of my hot water after, so I grabbed my mug. So you should get your adult to pour 1/3 of a cup of hot water. Now I'm going to put that water into my jar. So what I'm going to do is I'm going to swirl that around and try to heat up the sides of the glass. You'll still want your adult to do this part. So once I'm done swirling and everything I think is heated up really nicely, what I'm going to do is I'm going to take my hot water and I'm going to pour it over into my mug to get rid of it. And then right away, I'm going to place my ice cubes in my lid upside down on top of my jar. So I'm going to sit here for about 20 seconds, and you'll see something called condensation forming on the inside of the glass. So if you guys can see, I have a bunch of water droplets here that are sticking to the inside of the glass and making it harder to see through. It's kind of cloudy almost. So what I'm going to do after 20 seconds is take just a little bit of hairspray and spray it in there and put the lid right back. So I've probably waited about 10 seconds since I sprayed my hairspray in and put my lid back on. So as you can see, there's a lot of condensation going on in here. So we're going to release our cloud, and then we're going to talk about, well, how did this work and why did this happen? And how does this happen in real life? So let's release our cloud. So I'm going to take my lid off, and you can see my cloud rising out of the jar. And some of my cloud is still just hanging around in my jar. So let's put that aside and talk about what happened. Clouds are formed when air containing water as water vapor or water in its gas form contains as much as it can hold. And this is called the saturation point. And you can reach it in two different ways. So first, moisture or water will accumulate into the air until it reaches the maximum amount that it can hold. And the other way that this can happen is when the temperature of the moisture-filled air turns lower and lower and lower, colder and colder, and until it reaches the maximum amount of moisture it can hold. And this is reached through evaporation and condensation. Well, evaporation is what we saw earlier when we heated up our water, and there was steam or water vapor rising up from it. And condensation is the opposite. Condensation is when water vapor, or water in its gas phase, cools until it's a liquid. When something condenses to create a cloud, it needs something to condense onto. And, well, that's why we used hairspray. But I want you to think for a second on what would this be in real life? Well, the answer to that is things like dust, pollen, and even things like volcanic ash or air pollution. Well, obviously, condensation by itself doesn't cause precipitation. And like we said earlier, precipitation is rain, snow, sleet, and hail. Well, what causes precipitation then? Well, precipitation occurs when the moisture or the water in the clouds becomes heavy enough it has to fall. So this can happen in two ways. So in cold clouds, ice crystals and water exist side by side. So there will be a bit of an imbalance of water vapor pressure, and the water droplets will transfer over and stick onto the ice crystals. And the crystals will eventually get heavier and heavier until they have to fall down to the earth. In the second way that this can happen is when water droplets in warm clouds collide and bounce, like they have electric charges. So think of electric charge like you think of magnets. In magnets, there's a north and a south. So in electric charge, we have positive and negative. So if you try to stick two kinds of the same magnet together, the same two ends, they repel, right? They don't want to go together. But if you stick opposites, they attract. So the important thing to know about charge is opposites attract, but the same kind repels. So while they're colliding during this process, droplets with opposite charges will attract to one another and merge, growing heavier and heavier until their weight makes them fall. Another cool fact I have about fog and clouds for you are that they're basically the same thing. So fog is a cloud that simply happens at less than 50 feet. And a cloud just happens above 50 feet. So there are two main kinds of fog: radiation fog and advection fog. Now those are pretty big words, but just hang with me because I promise this gets cool. So radiation fog forms during the night when the Earth's surface cools, and the air right above that cools too, and in turn the air right above that. So when the air is moist enough, this cooling causes saturation, once again, and visible water droplets form. This kind of fog is also called ground fog because it's so close to the surface of the Earth. Well, what's advection fog then? Well, advection fog forms when warm, moist air, so humid air like we talked about earlier, moves over top of a colder surface. So advection means to move horizontally. So there's a lot more than two main kinds of clouds. I'm going to go over some of them just so that you guys can have the opportunity to take a look for them next time you're out enjoying nature. So we're going to start with high elevation clouds. So those are clouds that are super far from the surface of the Earth. They are between 16,500 feet and 45,000 feet. That is really high. So we've got three kinds we're going to focus on. So first we have the cirrus cloud. They're delicate, kind of feathery looking clouds that are made up mostly of ice crystals. And their wispy kind of shape comes from either the wind that twists and pulls the ice crystals into strands. So what does this normally mean for weather? Well, normally it means that a weather change is on the way. Next we have something called a cirrostratus cloud. They are thin, white clouds that cover the whole sky just like a veil, and they're most commonly seen in the winter. Sometimes they make it look like there's a halo around the sun or the moon, and they normally mean that rain or snow will arrive in 24 hours. And our last type of high-level cloud is the cirrocumulus cloud. They are thin and sometimes patchy. They cover the sky like a sheet. And sometimes they're full of ripples or made of small, tiny little grain-like clouds. Normally it means that there won't be precipitation, but it's normally pretty cold out. But if you live in a tropical region, these clouds could be a sign of an approaching hurricane. Next, we're going to go over some of what's called mid-level clouds. So these occur from 6,500 to 23,000 feet. That's still pretty high off the ground. So we're going to start with the altocumulus cloud. They're kind of a patchy white or gray, and they look to be layered. They're made up of very small rows of fluffy, ripply clouds, and they're lower than cirrus clouds, but still quite high. They're normally made of liquid water, but they don't often make rain, so it doesn't mean much in terms of the weather. Next, we have something called an altostratus cloud. They're normally a gray or blue-gray color, and they're composed of ice crystals. So they're made up of ice crystals and water droplets. They normally cover the whole entire sky, and they mean that there will be lots of rain and snow for a long time. Lastly, for mid-level clouds, we have the nimbostratus cloud. They're dark and gray, and they seem to fade into falling rain or snow in the distance. They're so thick that they normally block out the sunlight. They lead to gloomy weather with continuous rain or snow. Lastly, we're going to go over some low-lying clouds. So these are clouds that are less than 6,500 feet. Still pretty high compared to us, but pretty low in terms of clouds. So firstly, we have the cumulus cloud. They look like fluffy little white cotton balls floating through the sky. These are normally the clouds that you can pick out shapes in. They don't normally mean that any sort of precipitation is coming though, so the weather should be fairly good. Next, we have the stratus cloud. They often look like thin, white blankets covering the sky. Since they're so thin, though, they normally don't produce any sort of precipitation, but sometimes if you're in the mountains or the hills, they look like fogs. Normally this means the weather will be gloomy. We also have the cumulonimbus cloud. They grow on hot days when the weather is really warm and wet air, so humid air rises way high into the sky. From far away, they can look like huge mountains or towers. These normally mean that you should be on the lookout for rain, hail, or tornadoes. Our last low-lying cloud is the stratocumulus cloud. It's normally patchy white or gray, and they kind of look like honeycombs, like bees make sometimes. Normally it means the weather will be okay for now, but you should be on the eye out for a storm. We are going to finish off today with 4 special kinds of clouds. So the first kind of cloud that I find pretty interesting is something called a contrail. So contrails are actually made by high-flying jet airplanes. I'm not sure if you've been in one before. They're still clouds though, because they're made of the water droplets that come out from the water vapor from the exhaust engine of the jets. They can provide information about the different layers of moisture in the sky, but they don't mean much for the weather. Our second type of special cloud is the mammatus cloud. They're actually a combination of altocumulus, cirrus, cumulonimbus, and other types of clouds, and they kind of have pouch-like shapes hanging from the bottom. Well, what makes these odd pouches? Well, they're actually created when cold air sinks from the cloud towards the earth. This normally means that severe weather might be on the way. Our third type of special cloud is an orographic cloud. They get their shapes from the mountains or hills that they're forced either over or around. Sometimes sea breezes can form them too, and they normally look like lines where air masses meet. This is an early sign that there might be an afternoon thunderstorms. And our fourth and final type of special cloud is a lenticular cloud. So they're shaped like lenses, or almonds, or if you want to get really exciting, flying saucers. They get their shapes from hilly terrain, or just the way that air rises over something flat, like the prairies. They don't normally mean anything in terms of weather, though. Thanks again for tuning in to STEM with Simba, and I'm excited to be doing another activity with you guys next week where we will be making eggshell geodes. See you then!